Good morning. I am Reggie, Associate Professor, Department of ECE, Rogani College of Engineering and Technology, Kanyakumari. Today we are going to see the topic thermal control and propulsion. On completion, students will be able to explain about thermal control, describe the passive technique for thermal balance, understand about propulsion subsystem. Thermal control. It is necessary that the mean spacecraft temperature and the temperature of all the subsystems should be maintained within the limit suitable for satisfactory operation. Moreover, some device such as valve, thrusters, bearing and deployment mechanism may fail to operate completely if the temperature is too high or too low. Sources of temperature: radiation from the sun, radiation from the earth, radiation from the earth, action of the radiation falling on the earth and get reflected, heat generated by the equipments in satellite itself. Passive technique: within the spacecraft, the thermal balance can be achieved by using simple passive technique. Some of such techniques are appropriate choice of material, furnished, surface finish, insulation and heat conductor. Optical solar reflector are used on north and south panel. Antenna is made from graphene epoxy to minimize distortion. Multi-layer insulation is made of antenna reflector and to thermal gradient. Rear surface of solar plane black for high emittance. East and west panel of by the multi-layer insulator. Active method: thermal blanket and shield are used to provide insulation. Radiation mirror are used to remove heat from the communication payload. In Huggies HF-370 satellites, a mirrored thermal radiator is used. The radiator provides a path the generated heat to escape into the surrounding space. When the transponder are switched off, there will be a heat reduced in satellite. To compensate this, heaters are switched on at that time by giving command from ground. Propulsion. The propulsion subsystem is required for communication satellite to maintain a proper orientation and spin rate in transfer of orbit. Inject the satellite into geostationary orbit. Maintain the satellite at the correct longitude in the equilateral plane by station keeping. Help in aptitude control. Propellant. Propellant used for propulsion can be a liquid. Specific impulse. The characteristics that is used to describe the propellant performance is called specific impulse. It is defined as ISR equal to thrust unit of force by rate of propellant flow. F by W, F by mg, where W is the weight flow from the propellant, m is g is the acceleration due to gravity. Reaction control subsystem. Monopropellant system. Such system are especially used to restart capability. Error are corrected with less expensive of fuel. So from this we can understand that how a thermal control and propulsion is done. So the question is, what are the passive technique involved in thermal balance? Give a note on propulsion subsystem. What do you mean by bipropellant system? So here they clearly mentioned what are the active technique and what are the passive techniques employed in this thermal control and propulsion. So here we want to know about the bipropellant system as well as monopropellant system and how far the rate achieved in this thermal control and propulsion. Thank you.